Carnegie Mellon's John Anderson can tell what you're thinking. That is, if you're willing to solve algebra problems in a functional magnetic resonance imaging or fMRI machine. He has spent his entire life thinking about, well, thinking. Nobody has done more to shape a unified theory of how the human mind does all that it does. His work opened up an entire world for teaching machines to think like humans.
Your pioneering work in understanding how humans think enables me to be even smarter.
Growing up in Vancouver, Canada, Anderson was looking for something.
I guess I sort of wanted, in one way or another, to come to sort of a deeper understanding of human nature.
When he took his first course in experimental psychology at the University of British Columbia, he found his calling, cognitive psychology. But by the time he was a PhD student at Stanford in 1968, he recognized that there was a problem.
I certainly was unsatisfied with the nature of a lot of the research that was being done in experimental psychology. People would specialize in a single topic.
He wanted to unify all these topics into one theory.
I thought that was plenty ambitious at the time, but I guess my ambitions to try to bring together different threads just grew.
By 1976, Anderson forged even more strands of cognitive psychology and artificial intelligence into a powerful new theory. At its core was a blueprint for all human thinking. He called it ACT.
ACT stands for the adaptive control of thought. It's adaptive in the sense that it was capable of learning and adjusting to situations like humans are. It was control because it dealt very strongly with this issue of how thought has its structure so that it just doesn't randomly wander around but sort of leads in an appropriate direction. And it was concerned with the nature of the human experience, therefore the word thought.
ACT shows how the mind integrates all its functions. The production system acts as the traffic cop to keep track of sensory inputs and the mind's outputs. In 1978, Anderson joined the faculty at Carnegie Mellon. His colleague Ken Kadinger credits him with making the whole into something bigger than its parts.
It's like in physics efforts to unify theories and bring things together. John has done, like nobody else, that kind of unification in theory for psychology.
Anderson and Kadinger applied the ACT theory to real students. They developed computer-based tutoring systems, cognitive tutors, to help students learn math. In a 1987 interview, Anderson explained their revolutionary system.
What we've done is we've taken our understanding of human problem solving from cognitive psychology and the techniques from artificial intelligence to build intelligent tutors that teach mathematical problem solving.
The cognitive tutoring work that John started really culminated in the creation of a high school algebra course. That high school algebra course is used by about 500,000 students now every year.
Anderson built a worldwide community of ACT researchers, pushing the frontiers of what is known about the human mind and how to make machines reason like we do. With fMRI and the ACT computer program, Anderson can read this student's mind and predict what he's about to do. Anderson never stops thinking.
When he goes out the hall to, go get a glass of water or go to the men's room, he's still thinking about his research.
And what will be the result of all that thinking? Nothing less than a new understanding of what makes us human and how we learn and grow.
Certainly having children and kind of realizing what's at stake in education in terms of your own children certainly did a lot to motivate me.
Thank you, John.
The 2011 Benjamin Franklin Medal in Computer and Cognitive Science was awarded to John Anderson for the development of the first large-scale computational theory of the process by which humans perceive, learn, and reason, and its application to computer tutoring systems.